how do you read me?
Loud and clear, sir.
Can you see the board?
Yes, sir.
Yes, sir.
Okay. So we had done this formula GHA star is equal to GHA Iris plus SHA star. While we are at this diagram, I would like to show you two more things before I go on to the video. This black arrow we said is SHA star. Now I can go in this direction also, in the reverse direction. Does anyone know what I would name this direction as?
Right ascension, sir.
It is from Iris. If I go westwards to the star, it is called sidereal hour angle. From Iris, if I go eastwards to the star, then it is called right ascension. RIGHT ascension. ASCECEN ascension, generally known as RA, right ascension. One thing which you must remember, SHA plus right ascension is equal to 360 degrees. Sometimes in the question, you know, instead of giving SHA star, they will give you RA star, right ascension star. So you should not get confused. You should know what he is talking about. He's talking about the other direction, or subtract from 360 and you will get SHA. Depends how you want it. Is this point clear, gentlemen? Okay, I'll remove this to avoid the confusion now. So we discussed two reference points now. One is the Greenwich meridian. We can start a relationship either from Greenwich or we can start a relationship from Iris. Because we have to reach the star, and we said GHA star is not given for all the stars because it will make the almanac very big. So for one fixed point in space, Iris, the information is given in the almanac GHA Iris. So GHA Iris keeps changing because the Earth is rotating, but SHA star is fixed always. Very minor change during the full year. We will see why later on. So you can always take out the GHA star at any point of time you want. Which is the third reference point for which we are most interested? Let's say there is an observer. Meridian passing through observer. Oh, because I am the observer, I am standing at some latitude over here, maybe 15 degrees. I want my position, so I am also important because I have to find the angle distance from my point where the observer is. So observer is also very important. So third reference point is from the observer where. So all the angles which we measure from the observer are called the local hour angles. So just for your question to you, what is this angle from Greenwich to this? Just a question.
Longitude east.
Very good.
Longitude.
This is longitude east. From Greenwich, if we are measuring our position, we call it longitude. If I am to the west of Greenwich, my longitude is west. If I am to the east of Greenwich, my longitude is east.
East.
What will I call this angle? The red one. What will I call this angle?
LHA Iris.
LHA iris, because it is the angle, arc of the equinoctial or angle at the pole. Remember, this is the pole. Between the meridian passing through the observer and the meridian passing iris measured westwards. And what will be this angle?
Sir, LHA star.
LHA star, sir. LHA
Very
star.
good.
LHA star, sir.
LHA star. Very good. LHA star is equal to LHA star is equal to GHA star plus anyone?
Longitude.
As LHA star, this red angle is equal to GHA star plus east longitude.
East longitude.
There is a formula which I wrote in the beginning on top over here. If my LHA would have been from here, observer would have been in the west longitude, it would have become minus. We saw this yesterday. Try to draw this diagram, because if I make too many lines here, again you will get confused. So LHA star is equal to GHA star plus east longitude. Now GHA, if I know from the almanac, LHA I can calculate by practical navigation. I can get my longitude. This is the way we will be. This is our direction which we are going to take. How exactly we are going to find our latitude and longitudes. So, like the right ascension, I would like to point out one more thing over here. SHA, if I measure in the easterly direction, it is called right ascension. I can measure LHA also in the easterly direction. Let us say this was LHA star. If I measure it like this, what is it called?
Easterly or angle.
It is of no consequence, not important, but I'm just telling you in case sometimes in the question they will confuse you. If I go on the other side, it is called easterly hour angle. EHA. So remember, gentlemen, EHA plus LHA also is equal to 360 degrees. So this is understood by everyone?
Yes, sir.
SHA plus RA is equal to 360. EHA plus LHA is equal to 360. Any question on this diagram on the hour angle? Okay. I would like to tell you something more also over here. The last diagram on the slide yesterday. So try not to get confused. I will remove all this. Let me remove everything from here so that you don't get confused. Clear, everyone?
Yes, sir.
So now, okay, let me draw this. East, west, north, south. Let us say there is a body which is rising in the east and setting in the west. Let us say there is a body which is rising in the east and setting in the west. And I will continue with the equinoctial diagram. Let me make a body which is circumpolar in the sense it is always visible on the horizon. Let us say this is how the body has moved. And the observer is on the pole, let us say. And this is his main meridian, let me say north and south. Or you can say the observer is somewhere here. The point which I'm trying to make is that this is the observer's meridian. The observer is on this meridian. So when I draw the hour angle for the observer, or let me make it a little more simpler for you. Let me make this the observer. Let us say the observer is here. So wherever the observer is, there will be a north and there will be a south. There is no doubt about that one. And the body will rise in the east, the body will set in the west. So wherever the body is, if I draw a line like this, the meridian will pass through the body because the body is moving. And these are all meridians through the body. This is the observer's meridian. So what is the LHA? So let me number these also 1, 2, 3, 4, 5. There are 5 positions of the heavenly body, 5 meridians passing through the 5 positions. This is the observer's meridian in the north-south direction. For position number 1, this is the LHA. Yes or no? For position number 1, this is the LHA.
Yes, sir.
The angle between the slightly different. The diagram is not very correct, but just to give you an indication, let us say, because the finer aspect I can tell you a little later. Let us say this is the angle, local hour angle. For position number 2, this is the local hour angle. For position number 3, this is the local hour angle. And for position number 4, this is the LHA. And for position number 5, this is the LHA. Is this point understood by everyone? The LHA we are measuring westwards. So as the body is moving from here, the LHA keeps on increasing, right? If there is a body on the meridian, what will be the LHA?
Sir, 0.
If the body is on the meridian, that is over your head. If the body is over your head on the meridian, the LHA will be 0 degrees or 360 degrees. LHA will be 0 degrees or 360 degrees. Answer is correct. So in position 1, what is the LHA approximately? Tell me. 20 degrees.
20 degrees.
20 degrees.
Position number 2, what is the LHA?
Sir, 70 degrees. No, sir.
More than 90 degree, 120 degree,
Some
around
more than
110,
90.
120.
90 and 40, 130 degrees.
75. Yes, 100 degrees.
Correct.
130, yes, sir.
Position number 3 में कितना होगा LHA?
Sir, 210.
180 plus
210, yes, sir.
210. Position number 4,
Sir, 290.
290 degrees. And position number 5,
340.
340 degrees. Very good answers. Very good answers. The point which I am trying to make is, if you have understood the concept of LHA being 0 or 360 when the body is on the meridian. So when the body, we call it the superior meridian. When the body is on the inferior meridian, then what is the LHA?
90.
180 degrees. Other side. This is the superior meridian. When body is on your superior meridian, the body is going around like this. Then LHA is 0 or 360. When the body goes and turns around on the opposite side, the LHA is 180 degrees. What about the LHA when the body is facing west? What is the LHA when the body is facing west?
90 degrees.
90 degrees.
Yeah, if you have given me all these correct answers, 20, 130, 210, 290, 340, then it should not be difficult for you to understand what is marked in green. Yes? Because the local hour angle starts from the observer's meridian, which is 0 degrees over here. So, and it is to be measured westwards. So 90 degree westward is so much. 180 degree westward is so much. 270 degrees westward is so much. And 360 degree westward is, again you are coming back to the same meridian. Do not confuse this with the compass, gentlemen. Compass, this is north, this is 90, this is 180, this is 270. Compass is different. We are talking about the local hour angle, angle measured from the observer's meridian westwards. Any questions?
No, sir.
Okay. So now we come to another important point, the last point before I go on to the video. If the hour angle of any body, let us say this was a star, let us say this was sun, let us say this is moon, whatever, or a planet. Very important point, gentlemen, remember, if the hour angle of the body is between 0 and 180, then the body is lying to the west of the observer. If the local hour angle of a body, if the LHA of a body is between 0 degree and 180, the body is lying to the west of the observer, not west longitude. The body is lying to the west of the observer. If the hour angle of the body is between 180 and 360, the body is lying to the
180 to 360.
If the LHA of the body is between 180 and 360 degree, then the body lies to the east of the observer.
East.
Body lies to the east of the observer. Let me repeat once again. Local hour angle is measured from the meridian of the observer westwards up to the meridian passing through the body. So these are the local hour angles. There is one body here. You set 20, like this, all correct, which means LHA at this point is 0 and 360. So LHA at the, when the body is in the westerly direction, when the bearing is exactly west, is 90 degrees. When the bearing is north, body LHA is 180. When the bearing is east, LHA is 270. And when the bearing is again south, it is either 0 or 360. So yesterday there was one slide which was slightly incomplete. I will show you that slide once again, where I stopped earlier, and then you will understand, because it was not very clearly marked in the slide. So I will just share my screen. Switch off the camera for a minute. And I will take you back to the PPT. So if you want, I can just refresh your memory on this one. What I just did on the board, I will repeat the whole thing. Is it okay to repeat? Yes or no?
Yes, sir.
Yes, sir.
Yes.
This is where we had stopped earlier. Declination, polar distance. And we come to this, hour angles. So now maybe you'll understand better. We are looking from the north of the celestial pole. P is in the center. Greenwich meridian is down. 180 degree is above. There is a first point of Eris, and there is a star. So this is GHA Eris. This is SHA star. And the total is GHA star, which is what we had done some time back. GHA star equals GHA Eris plus SHA star. So if GHA Eris is 110 degrees, as you can see from the diagram, it is a little more than 90, so 110. And SHA star is 90, then GHA star is 200 degrees, which is correct because 180 meridian is on the opposite side and 200 degrees more, 200 degrees. All good so far? Okay, now we have put the star before and the iris later. In the previous slide, iris was before the star. Now iris is after the star. Any situation can come up because everything is rotating. GHA iris, SHA star, GHA star, same formula. Now we take the angles, then it will be more clear to you. GHA iris is 300, SHA star is 270. You add them, it is 570 minus 360. As GHA star is 210. Again, you can make out 180 plus a little more 30 degrees. GHA star is 210. I hope the diagram and the calculation is very clear to you, gentlemen. Yes?
Yes.
Okay. Now we come to local hour angle. Angle measured westwards between the meridian of the observer and the meridian through the body. Similar to D long, required for virtually all celestial calculations. So pole and Greenwich, west longitude, because body is to the observer is to the west of Greenwich meridian. Greenwich is 0 degrees, you know that. GHA star, LHA star. On the board, I had made 0 down below at the Greenwich. Here, O is over there. So as long as you remember the definition and from where to measure, it should be okay. So you can see over here, LHA star is the red one, GHA star is the blue one, and the longitude is the black one. So what formula are we getting? If you want LHA, LHA is equal to GHA minus west long. On the board I had made east long, which was plus. So if it is west long, it has to be subtracted from the GHA to get the LHA. And if it is east long, GHA star, LHA star. So GHA plus east longitude will give you the LHA star. Now going on a little further to what is LHA. This is what diagram I had drawn on the board. The vertical one is the observer's meridian. The observer is somewhere over there. So LHA of the body at the time of rising, in the sense when it is bearing east, is 270, because you are going around from this point. This is your observer's meridian and you are going westwards up to here. So when the body is rising and the bearing is east, the LHA is around 270. When the body is on the meridian, LHA is 0 or 360, then the body is either bearing north or bearing south. When the body is setting, bearing is around 270. At that time, LHA is 90, because you are measuring this angle from the observer's meridian to the body. And when the body is on the inferior meridian on the other side, the LHA is 180. So coming back to the conclusion, if the LHA of a body is between 0 and 180, the body lies to the west of the observer. Body lies to the west of the observer. And if the LHA of the body is between 180 and 360, the body lies to the
Easterly, sir.
East
Sir,
of the
east.
observer. East of the observer, huh? Not east longitude. East of the observer. Very good. So when we discuss nautical almanac, we'll discuss everything in detail. Let me show you a video on. There are two videos on the celestial sphere. Watch both of them very closely. I will stop in between so that I can explain to you also. But pay attention to each and every frame. Okay, I'll show you this one first. Have you got the video screen in front of you?
Yes, sir.
Yes, sir.
It'll take some time to start.
To understand the idea of the celestial sphere,
You can understand, hear the audio?
Yes, sir.
Okay. Okay, now let me first explain this one to you. The celestial sphere. You can see the Earth is in the center. And this is an imaginary globe with infinite radius extending out in space. This one is showing tilted. Right above the North Pole of the Earth, there is the celestial North Pole. And below the South Pole of the Earth, there is the celestial South Pole. In line with the equator is the celestial equator or the equinoctial. And the northern celestial sphere matches with the northern hemisphere of the Earth. You can see some parallels of latitude are drawn, some meridians are drawn. Parallels of latitude and parallels of declination are similar. Meridians of longitude and the celestial meridians are similar. By now, all of you must be very, very clear on the shape of the celestial sphere and what we are talking about. Is this diagram clear to anyone, or anyone has any doubt?
No,
If you are okay with this diagram, I'll move on.
Yes,
Clear?
yes.
Yes, sir. Okay.
Second diagram. This one is tilted on the other side, left side. But it is showing another one or two very important things. In the center, there is the Earth. By the arrow, you can see on the left bottom corner, the Earth is showing a little larger in size. Okay, can you see that?
Yes, sir.
Earth is tilted to the left. You can see the north and south pole of the Earth, and on the bigger sphere, you can see the north celestial pole and south celestial pole. Yes?
Yes, sir.
You can see the equator and the equinoctial, all of you.
Yes, sir.
Yes, sir.
The one in the center. Okay. You can see the red circle. What do you think is the red circle? It is written daily path. Daily path. It can be any heavenly body, maybe the sun. Yes?
Yes, sir.
On top, you can see between the celestial equator and the red line, there is delta D for declination.
Yes, sir.
Declination is north or south?
Sir, north दिख रहा है, sir.
Sir,
North
north.
declination. Very good. Very good. Near the north celestial pole, there is another circle showing as circumpolar. Can you see that?
Yes, sir.
Just like the red path, there is a smaller circle, but that circle is above the horizon. You can see the horizontal circle marked horizon.
Yes, sir.
So while the red circle is going below the horizon also, the small circle on the left is not going below the horizon. What does this mean, gentlemen? If you see my cursor, this circle is going, but not going below the horizon. This is the horizon. What does this mean?
Sir, it means observer can see that celestial body hold 24 hours.
Yes, very good. On the earth, if you see, there is one man standing here in the center. You can see this one where my cursor is.
Yes, sir.
Yes, sir.
That is the observer. That is the observer, and that is the latitude of the observer from the earth equator till this much. And then little beyond there is the North Pole. So I can say his latitude is about 40 degrees or 45 degrees maybe. Yes or no?
Yes, sir.
40 degrees, let us say. It looks a little smaller on this side. Transfer this earth come into the center over here. So there should be an observer on the top over here. Yes. Above the observer, if I take the cursor up, what can you read over here?
Zenith.
Zenith. So the point above the observer is the zenith, and the point right below it is the nadir.
The nadir.
All of you know this? And the
Yes,
pole,
sir.
the north pole which was slightly inclined on the left side, you can see the north celestial pole projected on the top, inclined on the left side. Is it clear?
Yes, sir.
Yes, sir.
Okay. At this point, I will like to explain to you one more important definition. What is a vertical circle and what is a prime vertical? Have you heard about this, read about this in the book or no?
Yes,
Yes,
sir.
sir.
वो सर लास्ट सर ने भी सिखाया था ये.
क्या किया था लास्ट?
सर जो लास्ट सर थे ना उन्होंने भी ये प्राइम वर्टिकल और प्राइम सर्कल बताया था.
The great circles which are passing through the zenith and the nadir are called vertical circles. But if this vertical circle is passing through the east and west points of the observer, then what is it called? It is called the prime vertical.
Prime vertical.
Now imagine in this globe, imagine many meridians or many great circles, not meridian, great circles passing through zenith and nadir. It can pass like this on the left, on the right, everywhere, correct? But they will cut the horizon in different point. You can see on the horizon east and west point where my cursor is moving. Yes?
Yes, sir.
And there is one north and south point. So wherever we are standing on the earth, we will have only one north and south point, and we will have only one east and west point. Am I right? The rest in between will be other degrees, no? 10 degree, 20, 30, 40. There will be only 190 and 270 degree and 100 and 180. Am I right? Yes or no?
Yes, sir.
Yes, sir. Yes.
So the vertical circle which is passing through the east and west points and the nadir and the zenith is called the prime vertical. Very soon in another diagram you will understand if you have not understood this point. Here the point which I am trying to tell you is now circumpolar. For an observer who is standing here, let us say at 40° north latitude, when he sees the sun rising, let us say the red line is the sun. The sun will rise at this point where my cursor is now. Can you see that point? Because this is the horizon, no? So the body, sun is rising like this. Yes?
Yes,
You
sir.
have to tell me yes or no.
Yes, sir.
The body is rising like this, sun is rising like this. The altitude is increasing. Altitude is increasing till it reaches this point. When it reaches this point, after this, the altitude starts reducing.
Yes, sir.
Altitude starts reducing. And when it comes here, we will say the body is setting. And then, अगर वो sun है तो अंधेरा हो जाता है. ये रात हो गया daily path में. Till again it rises here in the morning. Okay, I will ask you a few questions over here. Pay attention. If the body is rising here at this point, what is the declination, north or south?
Sir, north.
North, very good, because this is the east point. This is the
Yes,
east
sir.
point. Here also it is north because it is above the equinoctial. So this is the north declination rising in the east. Bearing has to be less than 90. I remember yesterday I told you. So bearing is somewhere around 70 or whatever. And when the body is setting, then what is the bearing?
Less than 270.
North declination. So again more than 270, 290.
Less than
The circle of declination which I made yesterday. This should be clear. Now what is the difference between the circumpolar body and this body, the red line? You will see that this body rises in the morning and sets in the evening, and there is a path which it takes place during the night time. But in the case of the circumpolar body, the body always remains above the horizon. It may be moving like this, altitude increasing, altitude decreasing, altitude increasing, altitude decreasing, but it is not going below the horizon, which means it is not setting. It is going around the pole. This is the North Pole, NCP. It is going around the pole, that is why we call it circumpolar body. If you are in the North Pole, if you are in the northern hemisphere, higher latitudes, and you observe some stars every day, you will know what I am saying. There is another body down below if you see near the South Pole. The declination is too much south. What is happening to this body?
it will never rise, sir.
This body
It
is
will
not
be
rising at
visible.
all. This body is not rising at all. It is always set.
Set.
This we will understand and learn more when you do a little bit of twilight chapter. But day and night and rising and setting of bodies, this is how it is explained. Here I would like to point out one more important thing. This is a good diagram to explain that one. If a body is rising over here, what is its altitude? I'm talking about the red line, the sun. When the body is rising over here, what is the altitude of the body?
Zero.
Sextant altitude.
Zero, sir.
Sir,
0 degrees. Very, very good. It is increasing, increasing, increasing till it reaches the maximum altitude. When it reaches the maximum altitude, what is it called? Till the time the body is increasing in altitude.
Meridian passage हमारे पास.
Meridian passage, very good. Till the time till the time altitude is increasing, the body remains to the east of the observer. LHA 180 to 360. The body remains to the east of the observer. When the altitude is maximum, there are different terms in theory question or otherwise if you get. The body at the highest altitude is said to be body on the meridian. It is also said meridian passage. It is also said body has culminated. The body has culminated. These are the different terms that are used. If someone says the body has culminated, you must automatically understand that the body is on the meridian and the body has got the highest altitude at that time. These understanding of these words is very important when you're doing principles questions. Sometimes they write like this in the question, the body has culminated. So you should know that the body is on the meridian or the body has attained maximum altitude. Because after this, what is happening?
Set. So the altitude will fall down, will decrease.
So it will
The
start
altitude
setting.
is altitude is coming down, down, down. Body now has come on the western side of the observer. LHA 0 degrees and increasing till the body is set over here. So everything that is seen in this diagram I have told you, explained to you. I hope have you understood, or is there any question over here? One more important thing which I can show you over here. From the celestial equator to the red line over here, this is marked D, that is the declination. What is this? From the celestial equator to the zenith, what is this distance marked as?
Sir, true zenith distance.
Louder?
The true
Sir,
zenith
true
distance,
zenith
T30.
distance.
True zenith distance. No. Somebody else try. This is the celestial equator, equinoctial. And if above this is the declination of the body, above this for the observer is what?
Polar distance.
Latitude, sir, latitude.
Latitude, very good. Polar distance is from the pole, gentlemen.
Sorry.
You see, you got confused when you said zenith distance or polar distance. That is for the body. Zx is the zenith distance. I will explain all that later, so let us not get confused. Here you just see north of the equator is the latitude, if it is the observer, and for the body, for the declination. So all clear? I think everything I have covered in this one. So let us move with the video, and then I think you will understand some more things.
To understand the idea of the celestial sphere, first think of the Earth in space. The stars all around us look as if they could be on the inside of a huge distant sphere. Though the stars are really at different distances, this idea of the celestial sphere is very useful for giving positions in the sky. Now imagine you are close to the North Pole. Here, it is like being on a roundabout because the Earth is spinning on its axis once a day. Every day, each star circles all around you and around the point overhead, which is the celestial North Pole. There is, of course, a celestial South Pole as well.
You can see in this diagram, you can see a star, but this star is set, rising and setting. So try to relate with whatever I have told you.
And the celestial equator circles the sky halfway between the poles. Positions on the celestial sphere are specified by two coordinates. Declination, like latitude on Earth, is measured in degrees north or south of the equator. Positive declinations are north, negative declinations south. Right ascension, the equivalent of longitude, is measured in hours from a zero line. An hour is 15 degrees. Because you are on the Earth's surface, half of the sky is completely hidden. The Earth gets in the way and creates your horizon. In effect, your personal sky is like a hemispherical dome. Imagine now you move to the Earth's equator. The celestial equator runs from east to west through the zenith, the overhead point. The celestial poles are due north and south on the horizon.
This is a very important diagram for you to understand. The red cone in the center is the observer. Relate to the previous diagram which I was discussing. The red cone in the center is the observer. You are standing, and what you see all around you are in the center. You are always in the center. Every observer will have a north and south point. If you have a compass, you will definitely know where is north and where is south. And you can see there is a green meridian drawn from the north celestial pole to the south celestial pole, and it is passing through the point over the
Zenith.
observer, the zenith. It is passing. So this green line is called the observer's meridian. When we do the rational horizon diagram, it is exactly this diagram made on a flat surface. Made on a flat surface. This diagram made on a flat surface. Green one is the meridian passing through the observer. And what is that red one? The magenta one.
Prime vertical circle.
Prime vertical, beautiful. What is your name?
Divya Kumar Saxena.
Divya, you are answering most of my questions yesterday also. So I'm sure you are doing a lot of studies. Very good. So that is the prime vertical. Because it is a vertical circle passing through the east and west point of the observer. Prime vertical is a vertical circle passing through the east and west point of the observer. All our rational horizon diagrams are based on this. There will be one circle and there will be one meridian passing through the observer, and there will be one prime vertical. I will show you this diagram on the board. I might take a couple of minutes today more, but that is okay. What is the other line of the star or the sun which you can see? What would you call that? That is the path of the body. It is the sun. Is it setting now or rising?
So setting.
Setting,
Setting.
sir.
It is, yeah, it is towards the west, no? So setting. And what is that green, light green circle flat on the surface? What will you call that?
The principal vertical circle.
No, the vertical circle is the red one. Green one is the observer's meridian. The circle down below on the flat surface where the observer is standing. What will you call that
The
circle?
rational horizon.
Rational horizon.
Yes, very good. That is called the rational horizon. Remember the equinoctial horizon? We were at the pole and the equinoctial was the circle. In the rational horizon is the circle. An observer is in the center. Very good. Some of you are giving very good answers. So let us move on with this figure in mind.
The north-south line on the sky through the zenith is called the meridian. At an intermediate latitude, the altitude of the celestial pole in the sky is equal to your latitude on Earth. Some stars are circumpolar and never set. It's sometimes useful to know a star's altitude its height above the horizon, and its azimuth, its compass direction. Azimuth.
This is another very good picture. The body is setting. The rational horizon is what is visible to you. And you have taken a sextant altitude. Sextant altitude is this angle. You can see the cursor.
Yes,
I
sir.
told you for the equinoctial we get declination and GHA. From the rational we get altitude and the azimuth, which we physically do. GHA declination we get from the almanac ready-made, but altitude and azimuth we have to take from the sextant and the azimuth circle. So sextant gives us this altitude, and what is the azimuth? See, compass starts from the north, go right round, body is setting, bearing about 290. So this is the azimuth. We will be discussing this azimuth and all these things in detail, but just to give you...
is measured round the horizon from north. But as the stars move, their altitude and azimuth constantly change.
So